1.1 Points, Lines, Planes, and Postulates. In this lesson, you will be introduced to some geometry vocabulary. We're going to begin with a point. A model of a point would be point P. It is drawn as a dot. It is named by one capital letter. It has no size or shape, and it indicates position. Symbols and words, we can write it as point P, writing out the word point, or you can use a dot for point P. The next item is a line. Arrowhead at each end to indicate it continues forever in two directions, named with two capital letters or one lowercase letter. It has no width or height. You can use line M or named with the symbol AH, the 2 points, with a symbol of a line on top, or HA. A plane. A plane is a slanted four-sided figure. It's named with 3 capital letters or 1 capital cursive letter or italicized. It extends forever in all directions, has no height. Plane Q or plane X, Y, Z using 3 points. The next item is a segment. No arrowheads, 2 specific endpoints, named with 2 capital letters. It can be measured, named forward or backward. It must be named with the 2 specific endpoints. If another point lie on this segment, I would still have to use the letters D and N. So I can write out DN with a segment symbol or ND with a segment symbol. And finally, we have array. Array has 1 arrowhead and 1 endpoint. The arrowhead indicates that it extends forever in one direction. It is named with 2 capital letters with the endpoint first. No matter which direction the arrow is pointing, the endpoint is always the first letter. It is part of a line, cannot be measured because it extends forever in one direction. A ray is always labeled with the endpoint as the first letter and a ray symbol pointing to the right. It does not matter which direction the original ray is pointing. The endpoint is always first and the symbol always points to the right. Let's look at some properties of points, lines, and planes. Points can be collinear, meaning they all lie on the same line, or non-collinear. They can be coplanar. In order to say that points are coplanar, you need a minimum of 4 points, as any 3 points are coplanar. They can also be non-coplanar, where you have 3 points on the same plane and a single point off of the plane. Lines can be parallel, they can intersect, or they can be skew. Planes can be parallel, they can be perpendicular, or they can simply intersect. Let's take a look at some postulates. The first postulate we have is the 2-point postulate. Through any 2 points, there is exactly 1 line. Line point postulate, a unique line contains at least 2 points. The line intersection postulate. If 2 distinct lines intersect, then they intersect at exactly 1 point. Plane intersection postulate. If two distinct planes intersect, then they intersect in exactly one line, as you can see on the diagram. 3-point postulate. Through any three non-collinear points, there is exactly one plane. Plane point postulate. A unique plane contains at least three non-collinear points. In this example here, I have many planes, and all of the planes in this diagram intersect these 3 points because these 3 points are collinear. So they exist on all of the planes in this diagram. This is why you need a minimum of 3 non-collinear points in order to name a plane.